Good morning, students. Today we will discuss about sets. Now, before discussing about sets, we will discuss about something related to sets. First of all, here I am giving some names. Euclides and Ramanujan and Aryabhatta and Pythagorean. Yeah, by reading of these names, what you are understanding? These names are famous mathematicians. How can you say that these names are mathematicians? Because from morning to evening we will do so many works. To remembering those works in our mind, how can we remembering those works in our mind? Our mind will take some sense and some order, and it will order to understanding those things. So it will have some related property or some rule or something important or something famous. So by seeing of these names, if these names are famous in a mathematics, these persons involved in a mathematics and they introduce mathematics problems. So these persons are famous mathematicians. So by seeing of some names, we can say that famous their work and what they are, where they are good at, and some property, some rule. We will relate it and will consider some sense, and immediately our brain will also activate, and that brain will says that this, by saying of those names, we can say that those are famous mathematicians. And same thing here. Sania Mirza, Saina Nehwal, and Sachin Tendulkar. And these names are related to sports. Okay, these persons are famous in sports. Okay, by seeing some names and some numbers and some colors. See here I am writing red, green, blue, yellow. These names are indicates the colors names. Okay, these are having some property. And same thing here, 5, 10, 15, 20, 25. What is the next of this number? 30. How can we say that? Because first of all we will observe those numbers, and by seeing of those numbers, what is the common rule of these numbers? See, 5, 10, 15. So which numbers? These numbers are multiples of 5. By seeing of some rule, we can understand these numbers are multiples of 5. So after 25, which number of multiple of 5? 30. So we can say that by saying order of these numbers. And 1, 4, 9, 16, 25. What is the next number of this? 36. How can we say that this number is 36? Because these all numbers are square of numbers. See here, 1 square and 2 square, 3 square, 4 square and 5 square. So what is the next number of this? 6 square. 6 square is nothing but 36. Okay. Here it is following some rule. Natural numbers we are doing square. 1, 2, 3. These numbers are natural numbers. These all natural numbers what we are applying? We are applying square to this natural number. So immediately after this series, what is the next number? We can say it. So these numbers are following some property or some rule. So those property or common property, which things are having common property, those we called as sets. So when you are considering in a set, those things should have common property. Okay, or well defined. What is meant by well defined? Well defined means we can define those things, whether those things are considered in a one group or not. Look at here, I am writing some names. mango, brinjal, and potato, and apple. Now, can I say these names comes under fruits? No. Why? In this, these some names are involved vegetable names. Here, brinjal and potato are comes under vegetable category, and mango and apple are comes under fruits category. How can we say that? By using some common rule of these names. Mango and apple considered as fruit names, and brinjal and potato are considered as vegetables. So, well-defined means it should be all objects should have same common property. So, these objects are not having common property. So, these are not considered as well-defined. So, when they are having the common property or common rule, those we called as set. Got it, everyone? Set is nothing but a collection of objects should have the common property or common rule, and those objects when you are writing in a set is called elements, and elements are separated with a commas, and set notation form is brass, notation with brass or flower bracket. Okay, this we called as brass or flower bracket. And when you are representing in a set, first we will start with one brass, opening brass, and 1, 2, 3, 4, 5, so on, and end with the brass. And what is the observation here? Here these numbers are separating with a comma. Okay, and these we called as elements. Okay, elements are separated with a comma, and set notation form is brass. Got it, everyone? And in this chapter we are going to discuss. And one more thing, when you are writing in a set, if anything is repeated, don't write in it double time. So, for suppose teacher. Now we are writing in a set. Now first letter is T, next E, A, C, H, and E. First already we written here, so don't repeat next time. R. When you are writing in a set, no element should be repeated. Now in these sets, we are going to discuss roster form. First one is roster form. And second one is set builder form. And next, types of sets. Finite set, infinite set, next empty set, or null set also you can call. Or invalid set also you can call. So here first one infinite, third one is empty set, next subsets, next cardinal sets, okay. These three are types of sets, and this is a subsets and cardinal set and universal set. Okay. Next, types of operations. See here, types of operations are union, intersection, next differences. Okay, these three are types of operations. Okay, now we are going to discuss roster form. In overall in this chapter, based on these two, we will have all operations and types of sets. First, we should know how to write in a roster form and how to write in a set builder form. Based on that, we will solve the problems. Yeah, now roster form. What is roster form? When you are considering some objects, when the collection of objects when you are writing in a set should have well defined, and we will use set notation from brass, and those objects when you are writing in a set, those we called as elements. Okay, and these elements are separated with the commas. These we called as set, and set this form we called as roster form. In roster form we will have elements. Okay, in a roster form we will have elements. What it? This is very clear, very easy also. Next is set builder form. See here, set builder form. We will write which elements are involved in that given set. We will write in a statement form or equational form. Okay. For writing that, first we will use set notation form brass, and we are considering this set only. These numbers are natural numbers, so we will consider x such that x. We will write this as x such that x. That means all objects are related with. Here belongs to, these all elements are belongs in natural numbers. Okay, and these numbers are up to L less than or equal to 5. Okay, what is meant by this x such that that means sets all elements are belongs to natural numbers, and up to how many numbers we are going to consider? Less than or equal to 5. So if less than 5, consider below 5 numbers, that means up to 4. Natural numbers are starts with 1, and less than 5 up to 4 only consider. What it? This less than or equal to means in that set again consider 5 also, included 5. Less than or equal to means consider 5. If only less than mentioned, consider only below 5. This is this set form called set builder form. And in examination, they will ask the roster form to set builder form, and set builder form to roster form also. For suppose 1 cube, 2 cube, they will give 0, 1, 8, 27 and 64. Write in a set builder form. So look at here, these numbers are 0 cube is nothing but 0, and 1 cube is 1, and 2 cube is 8, and 3 cube is 27, and 4 cube is 64. And see here, all our exponents are cube, and here bases are whole numbers. So when you are writing in a set builder form, x such that x, these all numbers are belongs to whole numbers, and 0 less than or equal to n cube. Here natural numbers are, these objects are in the form of exponential form. Exponent is 3. That's what we consider 3. Next, less than or equal to 4. Okay, 0 less than or equal to 4. Or else you can consider here x such that x cube also you can consider, and here no need to write 3. Okay, two forms you can write. X such that x belongs to whole numbers, and 0 less than or equal to n cube less than or equal to 4. First, you can immediately you can mention here x such that x cube also you can write. Here x such that x, and here n also you can mention what is happening. What if both are correct? This is set builder roster form to set builder form. Next, finite set. Here, what is meant by finite? Finite means we can finite. That means we can calculate how many numbers are involved in a set. For suppose here look at here, 5 multiples they given to us. So how many elements are there? 4. So is it countable or not? Yes, of course. So if when a set is countable number, countable set, that we called as finite set. That means countable number of elements involved in that given set. That set we called as finite set. Infinite set. See, whole numbers. So we will have undefined numbers, infinity numbers we will have. So in this set, how many elements are there? Here they mentioned up to, so on they mentioned. So that means we cannot count this. So it is uncountable number of elements involved in given set. So this set we called as infinite set. When the set is having so on symbol, that we consider as infinite, and when set is stopped, that we consider as a finite. Okay, easy to remember. And here I am giving some examples. Okay, say that which is finite and infinite. When the set is given in a closure form, we can say it is very easy to say finite or infinite. When set is given in a set builder form, how can we say that? Set builder form they are giving x such that x plus y belongs to natural numbers n less than or equal to 5. Okay, now see here, x plus 5, x such that x plus 5. Here n value is 5 and it should be equal to okay, x plus 5 equal to 5 and it belongs to natural numbers, and n value can be 5 or less than or equal to 5 also you can consider. Now less than or equal to 5 means in natural numbers we will get 1, 2, 3, 4, 5. If you substitute in x place, 1 plus 5 equal to 5. No, 6 is not equal to 5. And here next to 2 plus 5, 7 not equal to 5. So when you substitute these numbers in this set, this is not equal to. Okay, then how many elements involved to satisfying this? No elements. So this set doesn't having any elements. So this is how many elements are in this? 0 elements. So 0, is it countable or uncountable? Countable. So this set considered as a finite set. Got it? And also 0. How many elements are there? 0, nothing. So this set called as empty set. In that set, no element is present in that. That we called as empty set or null set or invalid set. For that we will use this sign. Okay. Next, one more example. X such that x square belongs to whole numbers and n greater than or equal to 5. Okay. See here, x square numbers and n greater than or equal to 5. So whole numbers are, they are considering here greater than or equal to 5 means 5, 6, 7. Greater than or means so many numbers you can consider. When you substitute here, you will get so many numbers. So is it finite set or infinite set? This set is a infinite set. Got it? When set builder form given to us, first read that set builder form equation and which equation they given to us and what is the condition they given to us. First look at here and after that convert into a closed form. Then we will understand that whether it is a finite or infinite set. And just now I discussed empty set. Now empty set means no elements present in that. How many elements are there? No element. So that set we called as empty set. In this, how many elements are there? 0 elements. So in an empty set we will have 0 elements. Got it? And for this we will use this symbol R size symbol. Okay, got it? Next, cardinal number of sets. Cardinal set means how many elements present in given set. First, suppose A equal to how many elements are there? N of A. We denoted with n, number of elements in a set. Okay, set name is A and number of elements in a set is 5. So this we called as cardinal set. Okay, how many elements, number of elements to discussing that set we consider called as cardinal number of set. Got it? N of A equal to 5. Got it? Next, universal set. See, universal set means all sets are involved in a whole set. The set called as universal set. For that we will use rectangular box and this symbol we will use. This we call as mu. Okay, to denoting of universal set we use this symbol. That symbol we called as mu, and representing of universal set is rectangular box. Okay, here I am taking some example. Natural numbers. In previous class we discussed natural numbers and whole numbers and integers and rational numbers and irrational numbers. These all numbers are involved in real numbers. So these all are called sets, and these all sets are involved in one whole set. That set we called as universal set. Got it? Which all sets are involved in a one set. That set we called as universal set. For universal set we will use rectangular box and denoting letter is mu. Next is subsets. Yeah, subset means what is the mean by subset? Set in one set is involved in another set. All elements are involved in another set. That set we called as subset. For suppose natural numbers or subset of whole numbers. To denote subset we will use this symbol, and natural numbers are all numbers are involved in whole numbers. So natural numbers are subset of whole numbers. Whole numbers are not subset of natural. Why? Because in whole numbers 0 is included. So natural numbers are subset of whole numbers. Next, whole numbers are subset of integers, and integers are subset of rational numbers, and rational numbers are subset of real numbers. Got it? And real numbers are not subset of rational numbers. Okay? This is subset symbol and this is not subset symbol. Got it? And how many subsets for given set? To calculating we will use 2 power n. This formula we will use. Here see, 2 is a base and is number of elements. 1, 2, 3. Here given how many elements? N is 3. This sets involve 3 elements. Now substitute formula 2 cube. 8 you will get. So for given set how many subsets you will get? 8. How to write this? First write in single element 1, 2 and 3, and next time 2 to combination 1 and 2 and 2 and 3 and 3 and 1. Okay, here if order is different also you consider as one set. 1 and 2 and 2 and 1 are same set. Don't write again repeated this one. 1 and 2 are 2 and 1 also same set. Next 2 elements combination finished and 3 elements. Okay, 1, 2, 3, 4, 5, 6, 7. Now every empty set is a subset of given set, and every subset, every set itself it is a subset. Okay, 2 sets are common, itself set and empty set. Rather than that, remaining all sets you can write first single element, next 2 combination, next 3 combination, next 4 how many elements are involved in that, based on that you will. For checking you will use 2 power n. How many sets you are getting? Here 8. So whether you are writing correct subsets or not, by using of this formula you can get that answer. Got it? Next is types of operations. Based on these all sets we will have the types of operations. Here union and intersection, and differences. Okay, for this first of all let us take those 2 problems. See here, A set involves 1, 2, 3, 4, 5 and B set is x such that x belongs to integers and objects are in 0 and 3. So first this set writing a roster form. What is the condition given to us? Integers and these objects are in between 0 and 3. So we can consider 0, 1, 2, 3, that's it. Now we written in roster form. Now take rectangular box. Just now I explained now, this is a mu and rectangular box universal set. Always you should remember when you are representing sets, this form we called as Venn diagram. When you are representing in a pictures, those we called as Venn diagram, and when you are representing sets in a Venn diagram, compulsory draw a rectangular box that indicates that inverse set and corner mention mu symbol. Next, how many sets they given to us? 2 sets. For 2 sets, use circular symbols. Now, for A set, what are the elements involved? 1, 2, 3, 4, 5 and B set 0, 1, 2, 3. So, which are common in this? 1, 2, 3. Right in a middle where it is intersected. And which elements left? 4, 5, right? Left side circle, and which elements left in this B set? 0. Right in second circle. Now this first circle considers A and second circle considers B. Got it? Now this part we consider as the intersection part where 2 circles meet, that we called as intersection. Okay. Next, remaining set elements we will write left side A set elements and right side B set. Remaining B set elements we will write left of the circle where A section is not, A set is not intersected to that circle. Now union. Union means together all elements we will consider. Union means all elements which are not repeated. Okay, all elements we will consider. To representing union you will use this symbol U shape, and union means all elements which are not repeated. So here already we written intersected numbers. So write in a order form 1, 0, 1, 2, 3, 4, 5. This is union, all elements which are not repeated. Next, A intersection B. Intersected means common elements. Which are common? 2 sets 1, 2, 3. Next, difference A minus B. Which is first set? A. What is the difference of B set from B? 4 and 5. When you are differentiating for A, you are comparing with the B. So what is the difference between A and B? 4 and 5 is the differences. So write it. Next, B minus A. Here, what is the difference between from B to A? So B set we should consider here 0. In B set, which is element is difference? 0. Got it? For A, which elements are differences from B set? 4 and 5. And B minus A means which elements are differences from A set? For B set, 0, element is extra. These are the types of operations: union, the intersection, and differences. And based on to checking of this, we will have one formula: N A intersection, A union B equal to N of A plus N of B minus N of A intersection B. Okay. See here, this is verification of this. N of means number of elements. So in the N of A and B, how many elements are there? 6 elements. So write it here 6. And N of A said how many elements are involved? 5. And B said how many elements are involved? 4. Minus intersection, B said how many elements we got? 3. Now 5 plus 4, 9. 9 minus 3, 6. 6 equal to 6. This is verification. For checking our problem correct or wrong, you can use this formula. Okay. By here we have union and intersection. By using the A minus B also, we will have one more formula. Here, to getting a N of A union B equal to N of A minus B plus N of B minus A plus N of A intersection B. Why? Because here already in differences we separated intersected elements. So that's what we are adding. Here we will separate and here we will add it. Next, N of A and B 6 elements, N of A and B is 2 elements, and N of B minus A 0 elements, and N of A not 0 1 element, N of A intersection B 3 elements. Now check it. 6 equal to 6. This is one more formula. Here A and B sets we are using. Here A minus B and differences sets we are using. Okay, these two formulas are very important. Got it everyone? These are the topics involved in sets chapter.